Okay, so here we go. This is the distance formula CG9. This is to find the distance from between 2 points, point A and point B. This formula can also be found on your formula sheet on the back. So here we go. To find the distance between 2 points A and B, first we're going to find the distance between the x coordinates. So we'll go x sub 2 minus x sub 1, that quantity squared, plus then we have the difference of the y coordinates, y sub 2 minus y sub 1, square that, and then add those up. Well, after you do that, then what you want to do is take the square root of both sides. That's why we have the radical here, because what we want to do is take the square root of that sum. So again, here we'll write an x2 minus x sub 1, that quantity squared, plus the quantity y sub 2 minus y sub 1, that one squared. Add them up, then take the square roots. Make sure you follow PEMDAS when you do. Square, then add. Don't add, then square. Make sure you square each individual term, then add them, then take the square root, or else you will end up with a different answer. Okay, so let's go ahead and take a look at an example. Let's call this point A, and let's call this point B. Point A, this is at 2, 6. Point B is at 5, 2. 5 units to the right, 2 units up. Okay, so now we want to find the distance between these 2 points. Well, according to the formula that we just got, the distance from A to B squared is equal to the difference in the x coordinates squared plus the difference in the y coordinates squared. Okay? Let's call B our second point. This will be x sub 2 and y sub 2. Let's call A our first point, x sub 1 comma y sub 1. Then the only thing left to do is do our little substitution into the this formula that we got, and we should be able to get going. All right, so x sub 2 minus x sub 1. X sub 2 we have 5, and then x sub 1 is 2. Then go to the next one. Y sub 2 is 2, and y sub 1 is 6. So it's 2 minus 6. The next thing that our formula said, well, take AB. I'll take the square root of both sides, so we'll go ahead and put a radical on the right-hand side. And then what we have is the square root of the quantity 5 minus 2 squared plus the quantity of 2 minus 6 squared. And remember, you want to square before you add. So let's go ahead and see what that looks like. So 5 minus 2 looks like we have 3. Add square that one, and then 2 minus 6 is a negative 4, but we're going to square that anyways. Notice that everything becomes positive because we're squaring each of these terms. So we're at 9 plus 16, which is equal to the square root of 25, which we know is 5. So that's how we'd use the distance formula. The distance formula is really, if you think about it, it is the Pythagorean theorem in disguise. What? I know. But let's go ahead and take a look. Let's see. What we can do, let's see if we can verify what's just said. Here is a right triangle. You can see it there in green. If in fact this is the Pythagorean theorem in disguise, what we have to do is be able to use a squared plus b squared is equal to c squared. Let's see if that works. Okay. So one of the legs of this right triangle is 1, 2, 3 units. Let's put a 3 there. Here we have 1, 2, 3, 4 units. So that's 4 there. Those are the lengths of the sides. Let's see if we can find the length of the hypotenuse and see if that's actually 5. So we'll go 4 squared plus 3 squared. Does that in fact give us 5? What we got when we use the distance formula. Now, let's keep going. 4 squared is 16. 16. 3 squared is 9. That's equal to c squared. Now we have that c is equal to the square root of 16 plus 9, which is 25. And in fact, c, the hypotenuse of that right triangle, is 5. So if you take a look, if you notice, the distance formula is the Pythagorean theorem in disguise. Right, mind blown. I know math does that to you. That's one example. Let's go ahead and take another look at a different example and see if we can make more sense of this, the distance formula and how to apply it. Here's example B. Now we want to use that same formula that we were given at the very beginning of CG9. So let's call this point A. Let's call this one point B. So now we can actually find the distance between A, B. The formula says the distance from A to B has to be squared, right? That's just the formula that we were given. And let's go ahead and see. Point A, this one here is at 1, 3, right? 1 unit to the right, 3 units up. Point B is at 7, 5. Okay? We'll call point B our second our second coordinate pair, and point A is going to be our first. So x sub 1 and y sub 1. Now we can go ahead and fill this out. We're going to find the difference in the x's, square that, then find the difference of the y's and square those. So here's the shell. Let's go ahead and do a little bit of substitution. X sub 2 is 7 minus x sub 1 is 1. Y sub 2 is 5. X sub 1 is 3. So there we go. Now what we have to do is take the square root of both sides. What we have is the square root of this first part here. 7 minus 1 gives us 6. And we can square that. 5 minus 3. Now that's 2. And we can square that. Let's clean this up a little bit. What we have is a square root of 36 plus 4. Let's go a little bit further and see if we can simplify this. Remember, what we want our answers to be is in simplest radical form. So we add those two up, we get 40. Let's simplify this. What we want to do is think of this. Think, is there a perfect square in 40? Matter of fact, there is, right? So we have, this is actually the square root of 4 times the square root of 10. 4 being the perfect square. The square root of 4 is 2. And radical 10 is just radical 10. And that is our answer. The length, the distance from point A to point B is 2 radical 10. Now, let's go ahead and take a look at it the other way. Let's see if we can use the Pythagorean theorem to get this answer. Okay, so the Pythagorean theorem. A squared plus B squared equals C squared. So let's go ahead and fill this out. Here is one of the legs. Here is the other leg. This leg is 2. This other leg is 1, 2, 3, 5, 6. This is 6. So we'll start off with 2 squared plus 6 squared is equal to C squared. Some of you may already see that, huh? This 2 squared plus 6 squared is way over here. 6 squared plus 2 squared. So we're already there, and we had to do less work. I don't know. You guys get to choose which ones you guys prefer. Next one. Then we have 4 plus 36 is equal to C squared. And then what we have up here, let's go ahead and clean that up a little bit. C squared is equal to 40. Take the square root of both sides. Radical 40 on the right hand side. 4 is a perfect square. Square root of 4 is 2. And we have still a 10 inside of the radical. So see, the hypotenuse of that right triangle is 2 radical 10. There you go. 2 different ways of looking at the same thing. Hopefully that was helpful. Remember, you can pause, rewind, rewatch these video lessons until you understand what it is that you want to understand.